In this video for the performance final exam review, I'm going over just the first two questions. So I'm going over Mock 7, and then I'm going to go over the Mock 8 questions, all three parts in each of those two. So in this first one with the radical functions, the first part was just solving for x, but then also making sure that we check for extraneous when needed. So like here, for example, we have to get the radical by itself. So first subtract 1 from both sides. Now I've got the square root of 5x, which is equal to 7. Now that I've got the radical here by itself, to get rid of it, right, square both sides. Now I have 5x, which is equal to 49. Now we can solve by dividing by 5, and x is equal to 49 over 5. Now here, notice how we can't do anything yet because the cubed roots are on the same side of the equation. We need to move that 1 over that's being subtracted. So we're going to add this cubed root here to both sides so that we can set them equal to each other. So now this radical cancels out, and now I can bring down and solve the cubed root of x plus 6, which is equal to the other cubed root, 3x minus 1. Because now notice, to get rid of our cubed root, we need to now cube both sides of the equation, right? What we do to one side, we do to the other. So now, canceling out, I've got x plus 6, which is equal to 3x minus 1. Now we can go ahead and just solve our multi-step here, solving for x. So I'm going to gather my variable and subtract x, and 6 is now equal to 2x minus 1. Then solve our two-step here. So adding 1, 2x is equal to 7, and then divide both sides by 2. So that's how you get here, x is equal to 7 over 2. Now in 1c, notice the radical is already by itself. So to get rid of it, we need to square both sides. So now here the radical cancels out, and we've got 11x minus 28 is equal to x squared. Now notice we're solving a quadratic, and quadratics have to equal 0. So I'm going to go ahead and subtract 11x from both sides, as well as add 28 to both sides. So now I can cancel out, and I've got 0, which is equal to x squared minus 11x plus 28. Now we can solve our quadratic by factoring. So what numbers multiply to get 28? Oops, sorry about that. I put an X here. Multiply to get 28, but add to get negative 11. Negative 7 and negative 4, because the two negatives, right, when multiply will make your positive, which means x is equal to 7 and 4. But now remember, right, we solved here by factoring. Let's check for extraneous. We need to plug into the original equation. So now notice this is just x here. So can x be positive 7? Yes. Can x be positive 4? Yes. So both x 7 and 4 are both a solution. So now here in part 2, we're dealing with this situation here with velocity, gravity, and height in meters. So the first part is you needed to solve for v. So here our formula is h is equal to v squared divided by 2g. So if I'm solving for v, well, right now it's being divided by 2g, so we need to multiply, right, both sides by 2g. Now I've got 2gh is equal to v squared. Now what can we do here to solve for v squared? Take the square root. So now we've got v is equal to the square root of 2 times g times h. So that is what v is equal to. So now in 2b, it's asking what is the velocity. So we're going to use this formula given our height, so h, 31.85 meters, and gravity, so g, 1.57 meters per second squared. So here we've got v is equal to the square root of 2 times g, which is 1.57, times h, which here is 31.85. So now notice you just got to put all that in the calculator, and the velocity is going to be approximately 10 meters per second. So now 2c says we're going to change the height. So we're going to change h 38.6 meters, but also how will it affect the velocity? So we're going to make that comparison statement as well. So again, v is equal to the square root of 2 times g, which is again 1.57, but times h, which is now 38.6 because we changed the height. Put this in the calculator and the velocity is approximately 11 meters per second. So how will this affect the velocity? Well, this made sure that the velocity increased by approximately 1 meter per second. So notice how here we're increasing, but don't just say that the velocity increased, right? Increased by approximately how much? 1 meter per second, because here we got 10, but then we increased to 11. So now part 3. We're solving our radical equation here, but then we do need to have explanation for each step. So I like just going through and solving first. So here I've got negative x, right, plus the square root. Let's write our problem. Now here, notice we need to add x, right, to get the radical by itself. So I'm going to add x to both sides. So the square root of 22 minus 2x is equal to x minus 7. And again, it's good practice to putting the variable first. Now notice we can start solving, right? The radical is by itself, so we can now square both sides to get rid of the radical. Now I've got 22 minus 2x is equal to, now notice here, you do need to do box method. That's x minus 7 times itself, x minus 7. So you should get x squared minus 14x plus 49 after doing box and combining like terms on the diagonal. Now you should have noticed we're solving a quadratic and quadratics have to equal 0. So we need to add 2x to both sides, but also subtract 22. And again, lining up those like terms. So now we've got x squared minus 12x, but plus 27. Now we can solve by factoring. So here, what two numbers multiply to get 27 and add to get negative 12? Negative 3 and negative 9, which means we are going to say here that x is equal to 3 and 9. But remember, right, what do you always have to do? Check for extraneous, but make sure to check for extraneous when where the radical was by itself. So we're going to plug in our answers into x minus 7, because this was here when the radical was by itself. So we need to plug in to x minus 7. So here we go. 3. 3 minus 7 is negative 4. So is 3 a solution? No, because we got that negative value here. Now let's check 9. 9 minus 7. Well, 9 minus 7 is 2. So can 9 be a solution? Yes. So 3 was extraneous and x is only equal to 9. So you now need to make sure when after showing your steps here, right? How can you make those explanations? So if you ever need to, right, go step by step. Like if you notice, what did we have to do in red? Well, we added x, right? But don't just say that you add x. Why did you add x? Well, I added x because the radical has to be by itself. Or you have to isolate the radical, right? So again, because sorry, as my pen is kind of wigging out here right now, sorry about that. But the radical has to be by itself, right? So again, don't just say add x. Why did you add x? Well, I added x because we had to isolate the radical or get the radical by itself. So just keep in mind whenever you're doing explanations, don't just say the one quick statement. You always want to put more than what you need. So in this case, you put the because. So then here, right? So like, what would you say for the next line, like the line in green? Well, what did we do then? Well, we squared both sides, right? So we squared both sides, or we raised both sides to the second power. Why did we square both sides? We squared both sides because we needed to now do the inverse of the radical. You see? So you need to make sure that when you are writing your explanations, you're putting the y. So then here, why did we add the 2x and subtract 22? Well, we needed to get 0. Why do we need to get 0? Because we're solving a quadratic. So notice how you need these because statements as you are going through here and writing your statements. But then, of course, don't forget to check for extraneous. So you need to check for extraneous. So that was truly the last step. And we had an extraneous solution. So now getting into the mock 8 question, we're focusing on the fact that they are inverses of each other, inverse functions. So like here, if we're getting the inverse, right, of 1a through 1c, you need to first make sure that you switch the x and y. Now we can go ahead, but first always get the exponential by itself, right? So we need to do the opposite, which is divide by 3. So now x divided by 3 is equal to our exponential. Now it's by itself, and you can write it as a log. So log base 5 of x divided by 3. Keep that all together in parentheses, which is equal to y minus 4. So now what do we have to do here to get y by itself? Add 4 now to both sides. So now you've got the inverse, which is log base 5 of x divided by 3, then plus 4 on the outside. So same thing again, right? We're going to get the inverse. So let's switch the x and y. And notice how we're starting with a log, so we need to end up with an exponential. Well, the log is already by itself, so now we can convert it with a base of 4. So 4 to the x power is equal to 4y minus 2. Now notice to solve for y, it's like we have a two-step here. So we need to add 2 first, right, to both sides. Always add or subtract. So we have 4 to the x plus 2 is equal to 4y. Then now you can divide both sides by 4. So notice our inverse function is here, 4 to the x plus 2, then divided by 4. Then 1c, same thing again, switching that x and y first before we convert our log. Now this log is not by itself. We're adding 16 to it. So let's subtract 16, right? Inverse, opposite. X minus 16 is equal to log of y divided by 2. So now we can convert it, but what is the base? Because it's not y, it's not 2. What's the base of our log? It's a common log, so the base is 10. So this is 10 to the x minus 16. Keep it all together because all of that is your exponent, right? All together is equal to y divided by 2. So now what do we need to do here to solve for y? Multiply, right? Both sides by 2. And this is the inverse function, 2 times 10 to the x minus 16. So now the last one, we have variables. We're solving for b. It is an exponential. We have to get that by itself, right? So we're going to add a to both sides because that's what's being subtracted. Now we've got c plus a is equal to our exponential of 2 to the b over e. Now we can convert. So we have our log base 2 of c plus a. Then remember, right, once you convert, make sure to close off and keep it all together in parentheses, which is equal to b divided by e. So now what do I have to do here to solve for b? Multiply both sides by e. That is what b is equal to. E times our log base 2 of c plus a all together. And so now in part 2, we're practicing identifying if 2 given functions are inverses. So you could do the proving by composition. I'm just going to go ahead and let's say use one of these expressions and just go ahead and get the inverse, just like what we did in the first part. So like here, for example, I know that this is the same as y. So this is really x is equal to log base 3 of y minus 5. Then just go ahead, right, and solve for y. It's already by itself our log, so I can convert. So this is 3, base 3, right, to the x power, which is equal to y minus 5. So now what do I need to do? Add 5 to both sides. So now I've got y is equal to 3 to the x, but then we added 5. So are these two inverses? No, they are not inverses of each other. Because, so why are they not inverses? Well, first off, notice how our functions don't match, right? But why don't they match? Well, keep in mind here, when we were doing our inverse operation, so here after converting to our exponential, if they were inverses, then we would have gotten 3 to the x plus 5, where x plus 5 is the exponent. But notice how it was only 3 to the x was our exponent. Then we added 5 last. So there's multiple ways that you can explain here after converting and using inverse operations. Here you ended up with seeing, no, that they were not inverse functions. But of course, make sure to identify that they were not, and then why. So you can go with your explanation all different ways. I'll do the same thing for 2b here. I'll go same direction. So here I've got my log. Now I'm going to say that, again, this is y. So x is equal to log base 6 of 7y. Again, the log is by itself, so I'm going to convert it, base 6. 6 to the x power is equal to 7y. So now what do you have to do? Divide by 7. So do these two expressions match? Yes. So I'm going to go ahead and go the other direction, right? Just to make sure. So x is equal to 6 to the y divided by 7. So what do we have to do first here to get the exponential by itself? Well, if it's being divided by 7, multiply, right? Both sides by 7. So I've got 7x is equal to 6 to the y. Now this can be converted because the exponential is by itself as a log. So this is log base 6 of 7x, right? Close it off, is equal to y. Notice they match. So are these two inverses? Yes, they are inverses. But why? So make sure to have your because statement. So they're inverses because after converting both of them using inverse operations, making sure before we do that, right, that the exponential or log was by itself here, right? Because we had to multiply by 7. So explaining your process. Then in the end, noticing how the functions ended up being the same. They were equivalent to each other. So again, make sure to explain and get your because in, but also make sure to identify if they are functions. In this case, they were. And so now in part 3, we're going to prove by composition that the following functions are inverses of each other. So notice how we do need to go with our work both directions. So here, I'm going to start off with 9 to the x plus 2. So I've got my base 9, but instead of putting x, what are we putting in the place of x here? We are putting the log. So this is 9 to the log base 9 of x minus 2. Then continue the function, right? Plus 2. So I'm going to also go ahead and I just realized I wrote the wrong parentheses. Sorry about that. So log base 9 of x, then minus 2. So now notice before we start simplifying and bases and exponents and whatnot, in our exponent, we have negative 2 plus 2, which is 0. So now we've got 9 to the log base 9 of x. Well, now notice we have a log property. The bases are the same. When the bases are the same, they cancel each other out, and we bring down the exponent that's left, which is just x. So notice how by using composition, we're left with x, which that's what we need if they are inverses. So now we're going to go the other direction, right? Now we're going to start with our log here. So we have log base 9, but now instead of putting x, what are we going to put? The exponential. So 9 to the x plus 2. Then continue minus 2. So now, same thing. I notice again, you've got your bases, right? Bases are the same, so they cancel out, bring down the exponent. X plus 2 minus 2. Then notice 2 minus 2, which is 0, and you are left with x, showing that they are inverses. So again, your explanation for the first, right? So here you are able to, so again, how could you explain? Well, after plugging one into the other, right? So after substituting one function into the other, after substitution, you were able to start eliminating, right? What did you eliminate? You eliminated the exponent, and you also were able to, if you notice, use a property of the log. So where the property of the log, where bases are the same. So notice how here, by explaining after the substitution of one function into the other, we were able to eliminate here in the exponent and use the property of the log. And because, and they are inverses, why? Because we are left with x. You have to remember that if you are left with x all by itself, everything is gone except for x, then that's why they are inverses. And the same thing here. Again, make sure to explain not just the first, but explain the second as well. Again, after substitution, we were able to first use the property of the log now. Then we were able to simplify 2 minus 2, which is 0. And again, you are left with x. So they are inverses because they're left with x. So you need to make sure to show your work here. But also make sure to have your explanation for both of those situations as well. And in the end, they are inverses because we were left with x in both situations.